Good evening, Honors Algebra. This is Mr. Lawrence with your flipped lesson for November 29. Today we'll be solving multi-step inequalities. Now, we're not going to go through and do one step and two step and then all that. I expect you to already know how to solve equations multi-step. So we're going to do one quick warm-up for an inequality, and then we'll go into some more advanced ones, and I expect you to be able to do them. If you are unable to do them, you need to come in for help specifically and tell me I'm not good at solving equations. All right, so quickly, we will do a small problem like this. Let's say we have 3 minus 2x, and that is less than, let's make it less than 7. All right. Now, I'm going to treat this problem exactly as an equation. If I need to, I'll go through my questions. What is my goal? To get the x alone. What numbers are keeping the x from being alone? The 3 and the 2. How are they attached? The 3 by addition. Hopefully you weren't thinking subtraction. Remember, it's a positive 3. So we look at the sign in front of the number. It is attached by addition. The plus sign belongs to 3. That negative there, that minus, that belongs to the 2. How is the 2 attached? Well, it's attached by multiplication. So I'll undo the addition with subtraction. I'll undo the multiplication with division. Saddam will tell me, don't forget Saddam, he will tell me to undo the subtraction and addition first. All right, so I'm going to undo the addition. Now again, some of you are going to want to put plus 3 here, and I'm going to do this wrong right here. Right, plus 3, that is incorrect. And I can prove it to you. 3 plus 3 does not equal 0. There's not a single person in here that would argue with me that 3 plus 3 is 0. If you're going to argue with me about that, you're foolish. You know 3 plus 3 is 6. We don't want 6. We want the 3's to cancel out. Therefore, I must use a negative. So I will subtract 3 from the left-hand side, subtract 3 from the right-hand side. And when I do that, sure enough, the 3's cancel. On the right-hand side, I have 4. On the left-hand side, I have 2x, but I have to bring down the negative. He belongs with the 2. They're a number. Negative 2 is an actual number. That negative belongs with him. If you separate them, it'll get sad. All right, now I will get rid of the multiplication. I'll divide by negative 2. Whoop, 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 whoop. Danger, Will Robinson. Whenever you divide or multiply by a negative, the symbol must flip. When you divide or multiply by a negative, the symbol must flip. When you divide or multiply by a negative, the symbol must flip. When you divide or multiply by a negative, the symbol must flip. When you divide or multiply by a negative, the symbol must flip. Yes, the less than becomes the greater than. Yeah. So when you do, did you catch that? I'm not sure if I said it. I better repeat it one more time. When you divide or multiply by a negative, the symbol must flip, meaning the less than must become a greater than. Or if it was a greater than, then it would become a less than. And don't tell me you get them confused, because this one looks kind of like an L, right? And less than begins with L. That's a less than. All right, if you hold up your index finger and your thumb on your left hand, you get a less than sign. Left hand, less than. The other way is the greater than. All right, now we have to graph this solution. When we graph it, it will be on a number line. So I will definitely show the point negative 2. I will show an open circle at the point negative 2. This should be review. And then I'll have to shade the numbers that are greater than negative 2. Well, the greater numbers would be to the right. And there is my graph. Okay, that should be review. I'm going to erase that underline I did because it looks like an equals 2. Oh no, I erased too much. There we go. So x is greater than negative 2. And now it might be smart to test it. Pick a number over here, say like 10. Pick a number over here, say like negative 10. All right, plug it in. Is 10 greater than negative 2? Good, then I shaded towards the 10. Is negative 10 greater than negative 2? No. And notice I did not shade that way. If you're wondering why that circle is open, put negative 2 into the inequality. Do you get a true statement? Is negative 2 greater than itself? It's not true. Therefore, the point is not shaded. All right, let's look at something a little more complex now. I'm expecting you to know how to solve equations. So let's take one like this. Let's go with 4s minus the quantity of 3 plus 5s, and that will be less than or equal to 17. All right, a little bit more advanced. I hope you're not thinking to subtract this 3 first. I will not do that first because that's not a 3. It's inside a quantity and there's a negative out front. I hope you're thinking, but Matt Bliznik knows the first step is to, big D word now, distribute. We're going to distribute the negative. Sounds like a title of a good book. Distribute the negative. All right. After I distribute the negative, I get 4s minus 3s minus, oh no, just minus 3. Oh, silly Mr. Lawrence. Hope you caught that one, James. Minus 3 minus 5s, and that will be less than or equal to 17. Now, Caitlin Keckler could tell you that it's time to combine like terms. So I'm going to go and notice I grab the sign on the 5s. It's a part of the number. When I combine my like terms, I only have s's that are like. I need to grab the sign. 4s minus 5s is negative s. The negative 3 didn't combine. He comes down, less than or equal to 17. Now I have, looks like a one-step equation. Technically, it's a two-step equation. So I will go ahead and solve it. I will end up with negative s is less than or equal to 20. I don't want negative s, I want a positive s, so I have to multiply by negative 1 or divide by negative 1. I'll go ahead and divide by negative 1 in this case. Whoop, 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 whoop. Danger, Will Robinson. Okay. A negative s divided by negative 1 is s. My inequality must flip. And 20 divided by negative 1 is negative 20. And I'm going to go ahead and graph that on a number line. All right. I have to show the point negative 20. Why? Because everything is contingent on that. S is greater than or equal to negative 20. I can show other numbers if I want. If I wanted to show 0, I could. I could show, say, negative 40 over here. But I don't have to. Might be a good idea, so I'll do it. All right. I'm going to have a closed point on the 20. Why? Because it's equal to, greater than or equal to. And then I will shade where the numbers are greater than negative 20. Well, I know that 0 is greater than negative 20, so I will shade that way. And there we go. Notice I'm doing my shading above the line. Makes it easier to read the stuff. Just make it clear that the shading goes on forever. Put an arrow on it. Let me know which direction you're shading. And of course, you have a closed point at negative 20 because it is a part of the solution. That is, if I plug in negative 20 greater than or equal to negative 20, is that a true statement? It sure is. So it must be a part of my solution. All right, I'm going to put 2 more up, and you can go ahead and pause the video and see how you do with them. Okay, here are the 2 problems. You can go ahead and pause. Work them out on your own. Number 2 won't be as much work. And then make sure you give number lines. Okay, when you're done, go ahead and unpause and you will see my steps appear. Okay, I'm going to distribute the negative 2. To get 3x minus 2x minus 8 less than or equal to 3x minus 8. Combine my like terms to get x minus 8 less than or equal to 3x minus 8. I don't like the fact that there are x's on both sides, so I will take away one of the x's. When I do that, I end up with negative 8 less than or equal to 2x minus 8. I'm finally down to a 2-step equation. I'll add 8 to both sides. oops, giving me the inequality that 0 is less than or equal to 2x. I'll divide both sides by 2. Hopefully you're starting to realize that 0 divided by 2 is a number. It is 0. And there we go. And now I can do my number line. I'll show 0 1, I'll show 5, I'll show -5. Go to do my shading. It will be a closed point at 0 because it's an equal to right there. And 0 is less than x. The numbers less than x are this way. So there we go. Okay. Now I will come over for number 2. Let me move this out of the way. Okay, number 2. It's just a, it's a multi-step equation, but it looks like a two-step equation. I'll subtract 4 as my first step on both sides. I'll get 10 is greater than, cancel, -5/3 j. There's two ways to do this one. I'm going to do it in one step. I'm going to multiply the whole thing by, actually I'm going to divide the whole thing by -5/3. That is one good way to do it. You could break it up into two steps where you multiply by 3 first and then divide by 5. Make one of them negative when you do that. Okay, but this is a little quicker. Those will cancel. I'll be left with j. Whoop, 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 whoop. I divided by a negative, so my inequality flips. And now I have 10 over 1 times -3/5. Well, 5 goes into 5 once, goes into 10 two times. 2 times 3 is 6, but it's a negative answer, so I get -6 is less than j. All right, I need to show my number line. I'm going to show -6 on there, 0, -12. -6 is going to be an open circle. And -6 is less than j, so numbers greater than -6 will make that true. So I'll shade where the numbers get larger. And there we go. All right, you'll get some practice with this in class tomorrow. Ah, man, I sure am loving these flipped lessons. You guys seem to be learning so much. All right, Mr. Lawrence signing off.